Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. What I'm going to do is to ask the user how many numbers do they want to see of this equation 2n squared plus 1. So whenever I have a number, if the user says I want to see 5 numbers of this type, we're going to plug in 0 into here, and then 1, and then 2, 3, 4, and 5. So from the 0 all the way up to the user number, that's how many factors we want to display for this particular equation. All right, so let me go ahead and give names to the various items over here. So this guy, we're going to call that txt user num for the text box. For the button, we'll call that btn display numbers. And then finally, for this label, we'll call it LBL result, like we've been doing for a majority of our programs. Okay, so let me just double check my work. txt user num, btn display numbers, and then of course LBL result. All right, I don't need the toolbox. I don't need the properties panel anymore. So I'm going to double click on this after I click save all. Okay, and so now display numbers. And I'm going to start off with my comments, declarations, get user input, calculation, followed by output. So those are the steps that we have to follow. Now you have to ask yourself, what are those things that are given to me by the user, and what are those things that I need to return to the user? And then you think of other variables that you might need. Well, first of all, I got to get the user number. So over here, dim user num as integer, because they're letting me know how many numbers they want to see. All right, I'm going to send out a list of those numbers over here. So I can just simply do that in the form of an output variable. So I can say dim output as string, and I can assign that string to nothing at first. It's blank. All right, whenever I see a series of numbers that belong to a pattern, the first thing that you should think of is repetition structure, or repeat. So we get one number, then another number, then another number as we plug them into our equation 2n squared plus 1. So that means I'm going to use a looping structure, which means I have to have a counter. So dim counter as integer, like that. Okay, well first of all, let's get the user input. So user num is going to be convert dot to int 32, whatever is inside of this text box, dot text. Now I've got the user number. Let's take that and start displaying numbers all the way up to a particular number. So in our calculation section, I'm going to let the counter start off at 0. So you'll see on the board what I've done is I've said let n equal to 0, and then it's going to be 1 and 2 and 3. Well, that's what this is. This is in essence the variable n, but we're calling it counter. So as long as that counter is less than the user number, we're going to keep on doing this over and over again. The user says, I want to see 5 numbers. Okay, so we'll plug in the 0 into the equation, then the 1, then the 2, 3, 4, 5. Okay, well actually, we'll plug in the 0 to 4 for those 5 numbers. All right, so that means I have to display something to the output variable. All right, what is it that I have to display? Well, first of all, I got to plug in the number 0 into here. 0 squared is 0, 0 times 0 is 0, plus 1 is 1. So when n is 0, the output of this equation is 1. Well, so why don't we do this? How about I create another variable over here that is the result, right? So we'll say dim equation result as integer. I could set this thing equal to 0 at first, and it is going to change when I work inside of this statement over here. So equation result is going to be, okay, let's go back over here. 2n squared, 2 times n squared plus 1, okay? So 2 times Now there is a function called pow. So I'm going to take that counter, which is my n, and then square it. And then plus 1. So this is the same thing as 2n squared plus 1. That's what this does. See the 2 over here? There's the 2. See the n squared? That's this part over here, counter squared. See the plus 1? That's this part over here. All right, and since I'm dealing with an integer, I can just leave it like that. That's fine, integer. So this equation has now been evaluated. Let's send that to the variable output. So output is going to be the old output, and I'm going to concatenate that with this new thing. So I'm going to convert dot to string whatever equation result is. And in this case, if this is 0, this whole thing evaluates to 1. So 1 is about to be displayed to the output. I better put a space after this. So I'm going to concatenate that with a space so I can distinguish all the numbers. Now that I'm finished with this, let's take the counter and increment it by 1. So I'm taking that counter value, increasing it by 1. Now, is 1 less than the user number? If it is, then we do this whole thing again, but this time this is going to be 1 to the second power times 2 plus 1. That will be sent to the output. Counter will increase by 1, and we keep on doing this for however many times the user wants to see that. When we're finished, then we'll say lbl result.text is going to be whatever output is. So if I run this program, and you're going to see the code down here. I'll move this out of the way. So here's the code for you. I want to see 5 numbers. Okay, 1, 2, 3, 4, 5 numbers. Notice that if this is 0, that the result is going to be 1. If this is 2, if n is 2, 2 squared is 4. 4 times 2 is 8. I'm sorry, I did that wrong. This is 1. 1 squared is 1, 1 times 2 is 2, 2 plus 1 is 3, there we go. Then this is 2, 2 squared is 4, 4 times 2 is 8, plus 1 is 9. Then this is 3, 3 squared is 9, 9 times 2 is 18, plus 1 is 19, so forth and so on, for however many numbers the user wants to see. So if I say 10, say for example, so you can see what that looks like. Or maybe I just want 3, you can see what that looks like. So this thing is a pattern of numbers that is being generated based on this equation. And there you go. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.